As we now know about vectors, what they are, the definition, some introductory stuff, okay, and then we saw its graphical representation, then mathematical representation, and we saw that how we can express our vectors in terms of its components. If it is in 3D space, three-dimensional space, then a vector is represented by three independent components. One is x, y, and the third is z. And it depends in which space you are considering. If it is in spherical coordinates, there will be three components, but their name becomes different. For example, in spherical coordinates, it's r, theta, and phi. Okay, and they corresponding, there are three correspondingly components for a vector. So it depends which representation you are considering, but it's always three. If it is in 3D space, you will have three components that are linearly independent of each other. That's the beauty of vectors, that's the very unique beauty of vectors. That let me elaborate this thing. It always happens with me when I'm talking about something, something else pops in my mind and I just want to tell you people and I really want to share with you, because I always wanted such a teacher who conveys the relevant extra information. So what I was sharing is that for example, if a vector is represented in three components, okay, so the vectors in x space, for example, the vector in x space will never interfere with the vectors of y space, and similarly they will never interfere with the z space. It means that they will never interfere with each other. They are having a separate party, they are having a separate party, and they are having a separate party. Only vectors in z directions, which are in z directions, can interfere with other vectors of z direction only. Okay, it will never happen that a z vector is interfering or affecting the y vectors. What does that mean? Affecting a vector means changing its magnitude or direction. Okay, so a z vector cannot change the magnitude of y component or its direction. Okay, that's something that I wanted to tell you, and the same is true for all these pairs that we have, because they are all independent of each other. They have separate parties, they do not interfere with each other. That's something that I wanted to tell you, and that's something linear independency means. Okay, you will be told about linear independence in linear algebra, but they will never tell you this thing. Okay, so yes, we'll see the application of this fact later on in solving the problems. Okay, so let's continue with equal vectors. What equal vectors are? When two vectors will be declared to be equal to each other. As we know, vector has two main things. One is magnitude and the other is direction. Now two vectors will be equal to each other if they have same magnitude and direction. Okay, both their magnitude as well as direction, if both of these are equal to each other, then the two vectors are equal vectors. So we can write it as like that. If we have two vectors, two or more vectors, okay, that's two vectors a and b, then or c, d, it can go on, or more, you can say two vectors a, b or more, then they are equal vectors. They are said to be equal vectors if their magnitude as well as directions are equal. Okay, it means their unit vectors will be same. It means their magnitudes will be same as well. So two vectors will be said to be equal to each other, and we can say that A vector is equals to B vector if A vector magnitude is equals to B vector magnitude, and we'll write and. Okay, sometimes some students write or. Or means either this satisfies or this satisfies. Even if one condition satisfies, then this is to no. Both of the conditions needs to be satisfied for this to be true. That's the AND operation. Okay, we know in digital electronics, the binary logic, what they are called as logic gates, AND gates. So AND statement tells us that both of these needs to be true in order to be this true. So, and the magnitude, which means A unit vector to be equals to B unit vector. Okay, so these are the equal vectors. Now let's talk about parallel vectors. What are parallel vectors? Let me use some other color. Parallel vectors. As the name suggests, parallel vector is related to the directions of the vector. Two vectors are said to be parallel vector if they have same direction. Magnitude is not necessarily be equal. Okay, that's not a necessary situation. If this situation satisfies, this satisfies or not, that doesn't matter. If it satisfies, then the two vectors are equal vector as well as parallel vector. If that doesn't satisfy, then at least the vectors are at least parallel vectors. Okay, if the two vectors are said to be parallel vectors, two or more vectors, you write two or more vectors, or said to be parallel vectors if their directions are same, or if they have same unit vector. Or if they point in same direction. Like, you can state a similar thing in different ways, but if they point along similar direction, they are all equivalent statements. So equivalent, if their directions are same, means unit vectors are same, then the two vectors are parallel vectors. What's next? It's anti-parallel vectors or anti-parallel vectors, whatever you like to call it. And anti-parallel vectors, and two vectors are said to be anti-parallel to each other. Two vectors, two or more vectors are said to be parallel to each other, to be parallel or anti-parallel to each other, if they point in opposite directions. That is what you can write mathematically. What happens is equals to negative unit vector of other vectors unit vector. Okay, unit vector is equals to negative of unit vector of second vector. So these are the anti-parallel vectors. Next is what is negative vector, negative of a vector, negative of a vector, or we can say the negative vector. Negative of a vector, negative of a vector is a vector with same magnitude. Negative of a vector A, let's say A vector's negative will be negative of a vector A is a vector with same, is a vector, let's say we call it as vector B, okay, with same magnitude but opposite direction, they have same magnitude but opposite direction. So negative of a vector A is equals to B. Let's say B vector is a vector which is negative of A, which means it has same magnitude as A vector but opposite direction, which means negative unit vector. I hope you got it. Let's say we have this as A vector starting point here, and this is the end point. This is A vector. What is negative of A vector? It's a vector with opposite direction but same magnitude, which means same length. This is negative A vector, and this negative A vector is actually the negative of vector A, okay, which we for differentiation called it as B, but it's a simple concept. If you see, the name itself suggests what we are talking about. Then we have a null vector. Null vector or zero vector. As the name suggests, 0 is a numerical value, so it's given to the magnitude of a vector. So null vector or zero vector is a vector with 0 magnitude. Since that vector doesn't have any magnitude, it means that it doesn't exist. But in vector addition, it sometimes happens that the vectors cancel out each other's effect, and we call the resultant to be the null vector, because it's the property of vectors that it always adds or subtracts to give a vector. So even if the resultant is 0, that resultant, null resultant, should be a vector, so we call it as a zero vector, okay. That is our imaginary vector that we call as we define it as having a 0 magnitude and arbitrary direction, like any direction. This is a null vector that we can represent by 0 with an arrow over it. That's a null vector. Next is some other vectors that we can see as some other additional categories I'll introduce to you people, because sometimes some students learns about them and some others do not. So that is an additional information. For FSC level, all the things that I have mentioned before that point are included as the basic concepts of vector. Other classifications are concurrent vectors and coplanar vectors. We'll see the definitions of them, like what are these vectors, okay. Unit vectors, we haven't defined it yet, so let me define them as well. And we have the collinear vectors, okay. So let us define all of these. First of all, I'll define unit vector because it's really important. We have defined null vector with 0 magnitude. We are familiar with unit vector as well, but we haven't defined it officially. So let us define it. What is unit vector? As the name suggests, it's a vector and it is assigned to some main vector, like as negative of a vector is related to some pre-existing vector A, like taking negative of it will give us negative of that vector, like we are relating a vector category to some other vector. This is similar here. Unit vector of a vector, let's say A, is represented by A with a hat over it. A shows that it is the unit vector of this vector, is represented by a vector, is a vector with magnitude 1 and points in the direction of A vector. It is mathematically given by, as we already know. Write it in comment section if you already know. Okay, it is mathematically given by A unit vector is equals to vector A divided by its magnitude, or we can write it as vector A divided by magnitude. Okay, this is unit vector. What's next? It's concurrent vectors. Concurrent vectors, the vectors, let me first tell you, concurrent vectors are those vectors which have their tails intersecting to each other, like their initial point is same but final points are different. Okay, so let's say these are A, B, C and D vectors, and they are concurrent vectors because their initial point is same or their tails are intersecting at a single point. Alternatively, you can say this. Okay, so these vectors are called as concurrent vectors whose initial point is same, or they intersect, their initial points intersects at single point. The vectors intersecting at a single point are called concurrent vectors. And this common point of intersection, this point of intersection is called as the point of concurrency, is called as the point of concurrency. The point of concurrency, let's draw these beautiful concurrent vectors with different colored markers. Okay, I'm so excited about this thing that I'm using the markers now, and in my childhood I was so excited when the arts class comes, because I really enjoyed drawing. As you can see here, these are all different vectors, but they are all starting at a similar point, and that point is called as the point of concurrency. Let's call this point of concurrency as O. Okay, so this is a concurrent vector. Now next, what's next? It's coplanar vectors. Coplanar, as the word suggests, coplanar vectors are those that lie on the same plane. Okay, coplanar vectors. The vectors lying in the same plane in the same plane, 2D plane, obviously, then because plane is a two-dimensional thing. Let's say if we have xy axis, if all the vectors lie on xy axis only, xy axis is a coplanar stuff, is a plane, xy plane we have, and if all the vectors lie are two-dimensional and two-dimensional along xy only, okay, then they're all coplanar vectors. But if one of those vectors that, you know, what we call a rebellious vector comes in, who is pointing in z direction is vertically upward, okay, so this vector is non-coplanar vector. Okay, this vector is non-coplanar because it is lying in the z plane as well. Okay, maybe in xy it has some component, maybe it has some component in xy, but it has component in z direction also, so it is a completely it's out of this xy plane. Okay, so I hope you understood it. If we have xz plane, for example, all the vectors lying in xz planes are coplanar to each other. So it means a three-dimensional vector is always a non-coplanar vector, because as I told you, plane is 2D thing. If a vector is in 3D, then it's obviously a non-coplanar vector. A vector could be a planar vector if and only if it is in 2D, and if it is parallel to the plane, if it is lying on the same plane. Okay, yeah, I hope you got it. The vector lying in the same plane are called coplanar vectors. Coplanar vectors. If you have any questions, you can ask me in comment section. The vectors which are not lying on the same plane, in the same plane, are called the non-coplanar vectors. And there is one thing that we can say for sure, is that a three-dimensional vector is always a non-coplanar vector. Three-dimensional vector is always a non-coplanar vector. But all 2D vectors are not coplanar to each other. They are non-coplanar vectors as well. As I told you, that it depends which plane you are talking about. There are infinite possible planes in 2 dimensions as well. Okay, so these are coplanar vectors. Now let's talk about the collinear vectors. That's the last category of vectors, I believe. Collinear vectors, they are really easy. Collinear vectors are all those vectors which are multiples of each other, which are any multiple of each other. Okay, negative, positive, fractional, whatever, but some multiple of each other. Two vectors A and B are said to be collinear if there exists a non-zero, because we are not including 0 here. Obviously, if you multiply a vector with 0, then that's not something we are excluding 0 here. Okay, so if there exists a non-zero number, let's say k, which is element of real numbers include all numbers, positive, negative, fractional, rational, irrational, but not imaginary numbers. Okay, imaginary numbers are different categories. They lie in different categories, and we are talking about real numbers. 1.5, 3.111115, 3.24, okay, all these numbers. So k is element of R such that this situation satisfies that A can be expressed as a multiple of B vector. Okay, k could be any number. So, and if what happens if k is greater than 0, it means if k is a positive number, then A and B are in same direction, because k is only a scalar multiple that is being multiplied to b, so it will not disturb the direction, it will only disturb the magnitude. Okay, a magnitude type of thing will only affect magnitude, and k is a scalar thing and magnitude is also a scalar quantity, so they will only affect each other, they will not interfere with the direction. That is why a and b will have same direction if k is greater than 0. If k is negative, obviously their direction will be opposite to each other, they will be anti-parallel. So if k is greater than 0, a and b are parallel. Parallel vectors, what happens if k is less than 0? It means if k is negative, like -1/2, -3/2, -1, -2, or any number like that, if it is negative, then a and b are anti-parallel to each other. Anti-parallel vectors. Okay, so that's all about collinear vectors. They could be parallel vectors or anti-parallel, but their magnitudes are scalar multiples of each other. Yeah, that's all about the classification of vectors. In this video we talked about the vectors, what they are, the definition, okay, the mathematical description, and then we saw the classification of vectors. That's a really important classification because we should know about these kinds of vectors. They are frequently used later on in derivations, and even in mathematics you will see their applications and their usage. So that was a really important lecture. In next video we'll see the addition of vectors and the multiplication of vectors. We'll see how to do scalar multiplication, how to do vector multiplication, what is scalar product, what is vector product, and what is scalar triple product, what is vector triple product, what are the shortcut methods to evaluate them if we are given a question. So we'll solve questions as well. These all videos will be uploaded and added in a single playlist that I'll link in the description box. That playlist name is I'll call it as calculus. Okay, it's a part of calculus, it's a part of EMT theory as well, it's a part of different things. So I'll link that playlist in the description box, whatever name I'll give it to it. So yeah, I hope you understood it. If you have any question you can ask me, and goodbye, thank you.